Alright, in this video we're looking at the last section of Chapter 5 and we're solving systems of linear inequalities. So by the end of the video you will be able to meet all three of our learning targets. Our first learning target is to be able to check solutions of systems of linear inequalities. Second learning target is to graph systems of linear inequalities. And third, write systems of linear inequalities. Okay, let's take a look at our core concepts. We're graphing a system of linear inequalities, which is going to be a two-step process. First, we're going to graph each inequality in a coordinate plane, and then we're going to find the intersection of the half planes. So we're looking really for that overlap region, and all of the points included in that overlap region will be considered the solutions to our system of linear inequalities. Okay, so our first example that we're looking at, we're just checking solutions. So we want to know if the ordered pairs are solutions to the system of linear inequalities. So we've looked at this with system of equations. All we're going to do is substitute in our values to see if the inequalities are true. So our first inequality, we're going to look at y is greater than 3x. So our y value is greater than 3 times our x value. When we simplify this, we get -1 is greater than -6. And if we think about this, if we looked at a number line, we know that this is going to be true. Next, we're looking at y is less than or equal to -x minus 2. So our y value, -1, is less than or equal to x value minus 2. So this becomes a plus, and we can see -1 is less than or equal to +2 minus 2 gives us 0. So -1 is less than or equal to 0. That is also true. So we can see that this point, yes, that this point is a solution to our system of linear inequalities. Okay, using the same approach, let's take a look at the point 0, 4. So we're going to substitute in this point to each of our inequalities. So when we evaluate the first inequality, we have 4 is greater than 0. So that is true. Let's substitute into our second inequality. We have 4 is less than or equal to a -0 minus 2. 4 is less than or equal to -2. So this is not true. This part of the inequality is not true, so no, this is not a solution to our system. Okay, so I'm going to graph now a system of linear inequalities. I have two inequalities. So the first inequality I am looking at is y is greater than or equal to -1. I know this is going to be a horizontal boundary line at -1. And I also know it's going to be a solid line because of the equal sign at the bottom. So I'm first going to draw the boundary line. Y is equal to -1. Next, I'm going to draw the boundary line for y is less than -x plus 2. So for this line, I know it's going to be dashed because there is no equal sign at the bottom. I also know that the slope for the line is -1 and the intercept is 2. So here's the boundary line for that inequality. And next I'm going to look at shading. So again, I'm going to check the point 0, 0 because it does not fall on either of the inequality boundary lines. So I'm going to check the point 0, 0 in my first inequality. And when I check this, I see 0 is greater than or equal to -1. And that's a true statement. So I'm going to include the 0, 0 in my shading for this inequality. So for my first inequality, all of this area is true for the solution. For my second inequality, I'm also going to check the point 0, 0. When I substitute in those values, I have 0 is less than 0 plus 2. So 0 is less than 2. This is also true. So 0, 0 is included in the shading for this inequality. So I'm going to shade that with a horizontal pattern. And I can see that the solution to this system is the overlap of the two shaded areas. So it's going to be all of this area up here. Now, you can use different colors for your homework. You can also use different patterns like horizontal or vertical lines or diagonal lines. If you notice in ALEKS when you're doing your homework or big ideas, the shading will be darker where the solution for both inequalities occurs. Okay, looking at the next example, so I have my first inequality. I'm going to rewrite this here. X minus y is greater than 2. First off, I know this is going to be a dashed boundary line because it doesn't have the equal sign. And then I'm going to put this into slope-intercept form so that I can graph it easier. So when I do that, I have negative y is greater than negative x plus 2. I'm dividing both sides by a negative 1. So I have to remember when I do that, I need to flip the sign. So I end up with x minus 2. So to graph this, I'm going to have an intercept at negative 2, and my slope is positive 1. So this inequality has a dashed boundary line. That's the graph of my first inequality. My second inequality, same approach. It's x minus y is less than or equal to negative 3. So I'm going to put this into slope-intercept form also. Then I'm going to divide both sides by negative 1. And since I'm dividing by a negative, I need to flip the sign, and I end up with x plus 3. So I have an intercept at 3 and a slope at positive 1. This is going to have a solid boundary line though because of the equal sign at the bottom of the inequality. Next, I'm going to check a point for the shading. So if I substitute in the point 0, 0 into my inequality here, I have 0 is greater than 2. So this is not true. So for the first inequality, I know that the point 0, 0 is not included in the shaded region. So here's the point 0, 0. For this inequality, I'm going to shade away from that point. For my second inequality, I'm going to check the point 0, 0 also. And when I substitute in the value, I get 0 is less than or equal to negative 3. This is also not true. So I'm going to shade the area away from the point 0, 0. 0, 0 is not included in the shaded region for the solution to this inequality. So if I look here at the overlap for the two inequalities, they do not have any overlap area, so there is no solution to this system. Okay, in our fourth example, we're writing a system based off of a graph. So we're working backwards. So let's start here with this boundary line. This boundary line is occurring at, we can see 2 units up on our y, so this boundary line occurs at y equals 2. And we can see that we're shading the area for the solution below this boundary line. So we know our first inequality is going to be y is less than or equal to 2. Okay, for our second boundary line, we can see that our intercept on this line is occurring at positive 1. We can also see that our slope for this line is a negative 1. So if we were to write the equation to the boundary line, it would look like y equals mx plus b. So here's our equation to this boundary line. But now we need to identify, well, what is the inequality symbol? I'm going to write my equation, and we're going to identify what inequality symbol goes here. So we can see that the shaded area that is true for this boundary is going to be this area above it or to the right. Okay? So if we were to substitute in the point 0, 0, this would not be a true statement for this inequality. So if I substitute in the point 0 for y and 0 for x, I need to have an inequality that would not be true. So 0 and inequality symbol 1. So if this is not going to be true, I would have to have 0 is greater than 1. 0 is not greater than 1, so this is a false statement. So that's what my inequality is going to be here. So my system, it's first y is less than or equal to 2, and my second inequality is y is greater than negative x plus 1. Okay, our last example, let's take a look at our system. So based off of the graph, we can see that this is a vertical line. So this vertical line is going to be in the form of x is equal to, and if we look at the value, it looks like it's a 1. Since we're shading to the right, it's going to be all values of x that are greater than or equal to 1. So the inequality looks like this. X is greater than or equal to 1. Next, let's take a look at our line here. So the boundary line is occurring at an intercept of -2, and we can also see that our slope is 1/2. We're going up 1 unit, to the right 2 units. So our equation to this boundary line is y equals 1/2 x minus 2. Now for us to write the inequality, we're going to set this up and identify what inequality symbol goes here. Well, if we look, the shaded area that is true for this inequality is above the line, which does include the point 0, 0. So when we substitute in the point 0, 0, we should end up with a true statement. We need to make this a true statement. So in order to make this true, 0 is greater than or equal to -2. So that's our inequality symbol here. So this is our system of inequalities.